going to take this question. This is actually not from this standard exam style questions. This is uh, I have taken this problem from this Instagram page. This beautiful page actually. I'm referring this page always to get these problems. These problems are more into Olympiad uh, Olympiad exams, right? Anyway, this is interesting to go through these questions to recap basic theories, right? Um, you can pause the video and give it a try. Now, I hope you have given some try. So I will give you the basic explanations about uh, three theories that we can use to solve this problem. This is basically into geometry, right? Where we deal with all these lines, angles, shapes, and the spaces, right? Now, to explain the basic theories, the very fundamental theories we're going to use for this question. Now, if you consider this shape, this two-dimensional shape, a square, right, where all the sides are equal to each other. So this is how I'm going to prove this Pythagoras theorem from the fundamental idea, right? You take this square and let's say actually this is a land you own, okay? So we have this land we are owning, and let's say this side is A, this side is also A because this is a square. Let's say there is another square. We own something like this, right? In this way. Let's say this is B, so this is also B, right? So we know the area. What is the meaning of area in geometry in these two-dimensional spaces? This is actually a two-dimensional space. It doesn't have any thickness, so this is just a flat surface, right? If you look at from the top view. So the space inside the two-dimensional space, we say the area, right? What is the area of this square, which is A into A? That is A squared, right? And this is B squared, okay? For some reason, let's say you own these two lands and there is a new road being proposed, a new road being proposed from the government, let's suppose. So for that case, both these two lands are going to be destroyed, right? And the government is offering you a new land, uh, where you're going to have these two areas all together, right? So you're not going to miss any area. So this new land government is proposing uh, something like this. You're going to have a new one land. I think I have to get this down. So your new land would be something like this. It is going to be a new square placed on this this new line. So government says to you, this is a new square land where where you would have both these two areas added, right? That means the area of this new land would be A squared plus B squared, right? So this is a simple experiment you can try. You can draw this thing on a paper with correct measurement, so it would work, right? So if you take a square, uh, um, let's say we have a square here, 3, 3, right? And we have another square, uh, something like this. You can try this. I'm proving the fundamental in Pythagoras theorem. Let's say this is 4, 4, and you will have a new square here. You will have a new square, something like this. So what should be the new area of that? You should know this area. This is 3 into 3, 9. This is 4 into 4, 16. This is exactly going to be 25. 25. So in this case, this one side would be 5. This one side would be 5. So if you consider this, this triangle is a special triangle, right? This triangle is a special triangle, which is known as a right angle triangle, where one angle is 90 degree. Okay, this is 90 degree. Because this is 90 degree, that's obviously 90 degree. So this triangle, if you extract this triangle, so this is where we come into the core of the Pythagoras theorem. You take any right angle triangle. This works for any right angle triangle. Um, let's say this one side is A, this one side is B. This is right angle, 90 degree. The side in front of the 90 degree is known as a hypotenuse. Hypotenuse, we'll name it as H. Okay. So Pythagoras theorem states that the square of hypotenuse is equal to the sum of square of this square of the sides. That's it. So you can use this theorem for the question given, right? 1 point. You can still keep trying. Now, the next theorem, you take any shape. I'm going to take a triangle, any closed shape. Well, we say this is rectilinear, plane figures. All these are plane figures, which are two-dimensional. Okay, I'm going to consider this triangle. Yeah, and we have three angles here. Let's name it as alpha, theta, beta, right? So and we're going to have these three sides. Let's say this is P, Q, R. Okay. Now, what I'm going to do, these three sides, I'm going to multiply by a common number, right? So what will happen to this triangle? Either this will get enlarged or shrinked, right? So if I multiply this each side by 3, what will happen? It will get enlarged, right? Keeping the same shape, nothing will change. I mean the shape, but I mean the structure of the shape, but it will get enlarged, right? So you can see if you multiply this by 3, what will happen? You will have the same kind of triangle, but enlarge, something like this. 3 times it is getting enlarged, isn't it? So something like this. Okay. Right? So this new side is going to be 3 times P. This is 3 times Q. This is 3 times R, right? So as we have the same proportions of the sides, the angles won't be changing. This is going to be theta. This is going to be alpha, beta. That's why I said the structure is not going to be changed, but the shape is getting enlarged in this case, because this is 3. If this is a fractional value, what will happen to the triangle? It will get shrinked, right? It will get shrinked. So we say these two triangles are similar triangles. Similar triangles. So similar triangles are the triangles which are having same angle, same interior angle, same exterior angle. So these angles are similar, right? So three angles are there to be matched. If two angles are, if you can match two angles out of these three angles, these two triangles are getting identified as similar triangles. Okay. So what is the property? What is the outcome of this identification? Similar triangles. The corresponding sides are proportional to each other. They have a same number. So if you divide this 3r by, so okay, first you identify this angle. This is alpha, this is also alpha. You take the opposite length of alpha. Here in this case, 3r. If you divide, let's say, let me name this as 1. This is 2. So 1 to 2 are going to be proportional, the lengths. So 3r divided by r should be equal to 3p if you take the opposite length of beta, right? 3p divided by p. Also, it should be equal to 3q divided by q. That's obvious, right? R gone, p gone. That's going to be 3, right? So they're obviously equal. So that's the idea of similar triangles. We can use that theory for the question given. Yeah. If you identify two triangles in the question where two angles are similar, so you can prove these two triangles are, if you find two angles are same of these two triangles you consider, you can prove these two triangles are similar triangles, then you can apply this pattern, this characteristic, right? You can use that. And yeah, so if you take this triangle, next one, you take this triangle, uh yeah, I'm going to find the area of triangle, right? Area of triangle. For to prove that, you take you consider this rectangle. You know the area of a rectangle, which is L and B, length and the breadth. So you know the area, which is L into B, right, of a rectangle. If you break this, if you split this into two, we're going to have, this is 90 degree, right? This is 90 degree. So you're going to have a triangle here, right? So what should be the area of this triangle? This is exactly divided into two parts, right? Yeah, half of LB, right? So we modify this thing. This is the area, the area of this triangle. We modify this into general triangle. You take any triangle. You consider this as your base. So you need to know the perpendicular height. That means the shortest distance, this is very important. The shortest distance between the top level, this is your top level with reference to the base. This is your base, it's like a ground level. So the shortest distance between the top level and the bottom level, we consider that as h, perpendicular height. So that is the shortest distance should be perpendicular height. So you can just write down, just show here, right? That is the same h. Same h. This is going to be same h wherever you mark it. Yeah. So area of this triangle is going to be half base into the perpendicular height. That's it. You can use these three theories to try this problem given, right? Area of a triangle, similar triangles, and the Pythagoras theorem. Now, if you go into this thing, okay, let me just sketch over here. Now, uh, yeah. Now, how I'm going to approach this. Now, as they have given this is, let's take this as x. And that is a right angle triangle. You can see that this is not a right angle triangle where the area is given 84 square centimeters. How we can approach this? Mm, we can identify some similar triangles here, right? Similar triangles. How we can identify that? I said this is going to be 90 degree. So if you consider, let me mark some letters. Let's say this is P, this is Q, this is R. I don't know, this is N, M, right? So you can see, if you consider, if you consider P, yeah, PQR triangle and PNM triangle. What do you think? This angle. This angle is a common angle for both these triangles, right? Right? It's a common angle, so they are equal to each other, right? And this is 90 degree. This is 90 degree. So out of three angles, two have been matched. So we can say PQR triangle and PNM triangle, they are equal to each other, right? So I'm going to name some uh, lengths over here. So let's say this as A, right? So this side is going to be 7 plus A, right? And we can have this as B. No need to have so much of letters, but to simplify that, I'm going to have this letter B, and let's say this as C. This C. Okay, this C. Now, let's try to simplify this further. So this is they are similar. They're similar, right? Just name them like that. Similar or whatever, right? Now, now, if you consider the area of this yellow color triangle, we can write half. We consider A as a base, B as the perpendicular height, right? I said the shortest distance between top and the bottom level, which is B, that is 84, right? So AB is 84 into 2, AB is 168. So let me write B in terms of A, 168 over A, right? So we have this in terms of A. Now, what I'm trying to find this C, right? If you find C, you can see this right angle triangle, you can apply the Pythagoras theorem and find X, right? So I'm trying to find C. Now, how you can find, because we know PQR triangle and PNM triangle, they are similar triangles. So I'm trying to apply the proportionality, right? Let me apply the proportionality between PQR triangle and PNM triangle. So it is going to be, you consider PNM triangle, the bigger triangle. If you consider the C plus B length, the whole PM, okay, let me go with the letters. PM length to PM length to PR, they are proportional, right? We have to consider the angles actually, right? So you should know this thing. This angle is going to be equal to this angle, right? Because they are similar. So you consider this right color angle and look at the opposite length. So N angle, if you look at the opposite length, that is PM. So PM divided by PR should be equal to uh, QR. So you consider the bigger triangle first. So NM over QR, right? Yeah, I'm actually looking at this P angle and the opposite sides, right? So I'm going to apply this. PM is what? PM we can see C plus B, right? C plus B. C plus B over PR is C equal NM is what? 7 plus A over A. Yeah. So um, we can actually divide this each term by the denominator, right? We have an addition. So this addition can be divided by separately by the denominator. So that's going to be C over C plus B over C is 7 over A plus A over A, right? So C gone. This is 1 plus B over C is 7 over A plus 1. So 1 gone. They're getting cancelled. B over C equals 7 over A. So C is going to be BA over 7, BA over 7, right? A we know B, so that is 168 over A. Let me put that here. A over 7, so A gone, 160, 160 over 7. We can keep that, that's okay. That's my answer for C. Now you consider this triangle, this right angle triangle, this triangle, where this is C, this is 7, this is X. So you apply the Pythagoras theorem, C squared plus 7 squared equals X, right? So C squared is going to be 168 squared over 7 squared plus 7 squared will be your X squared. So this 160 over 7 is actually 24 if you get this answer. If not, this is going to be more complicated. So let me get that answer properly. So this is going to be 24, 168 over 7. That's 24, right? So this is 24 squared plus 7 squared is X squared. What is that answer? 24 X squared will be 576 plus 49 is X squared. So X squared will be 625. So X will be root 625. X would be 25. Maybe this is too complicated. I'm going to uh, uh, share the link of this Instagram page where they have very straightforward methods. But I wanted to discuss the theory referring this question. So when it comes to Olympiad, we have to see some alternative and creative ways of applying the mathematical theories in different perceptions into these problems. In this case, in this video, I wanted to go through the theories where we actually we deal with these theories in all the exams, international exams, right? So I wanted to go through this theory referring this Olympiad problem.